let's look at ideal gas equation. Like I told you, an ideal gas equation must have pressure, volume, temperature, including number of moles, for it to make the constant, for it to make it an ideal gas equation. Alright, so we say that an ideal gas must have pressure, temperature, volume, and number of moles for it to be an ideal gas equation. Now, not only having all these things, before it gets to the molar gas constant, it must have pressure and volume varying above the temperature, inclusively with the number of moles. Now, the number of moles makes it a known, let's say, a known gas. That's just it, a known gas. Not like oxygen is a gas, a known gas. That is with the number of moles, we will know the type of gas that it is. Okay, now let us look at some things. They gave us a constant in the molar gas constant. Remember, I told you that PV over NT equals to R, like PV equals to K, P over T equals to K. That constant. Now they are giving us the constant. The constant is 0.082 atm dmq Kelvin and mole. Just 0.082. Don't forget this thing. You may forget this, but don't forget this. Okay, now let's go to the questions that we have on the board, which can explain whatever we are saying here. Alright, we have the formula to be PV equals to nRT. This pressure volume equals to number of moles times molar gas constant times the temperature. Remember, the temperature is in Kelvin. Even though you see the temperature in centigrade or Celsius, change it to Kelvin. Alright, the question says calculate the number of moles present in a certain mass of gas occupying 6.5 dmq at 3 atm and 50 degrees Celsius. So what you do is you change your temperature to Kelvin and you put your formula. That is what we did. 15 plus 273 equals to 288 Kelvin. Now this is our formula. We want to make n the subject of the formula. Now we divide through by the coefficient of n, which is RT and RT. RT cancel RT, making n the subject of the n equals to PV over RT. That's what just happened there. So PV over RT equals to n. That means P is 3 atm times 6.5, which is volume, all over 0.82, which is our molar gas constant, times 288. In every question concerning ideal gas, they will give you this molar gas constant. In every question concerning ideal gas, they will give you the molar gas constant. If they didn't give you, you are asked, then you know that you are asked to find it. Maybe they gave you the P, they gave you the V, they gave everything, but didn't give you R, they are asked to find. Okay, that's that. We move to the solution. 3 times 65 all over 0.082 times 288. The 288 is for the temperature. Now, if you press your calculator, you see 0.83 moles. 0.83 moles. I think that is the answer for this. 0.83 moles. So, the moles is now the n. Number of moles. Alright, this now determines it as an ideal gas. Without this, it's not an ideal gas. Just in another case, maybe that you may see a question, they ask you to look for temperature, ask you to look for R, look for number of moles, look for P or V. They may ask you, they may also say, calculate the number of moles present in a certain mass of gas occupying 6.5 dmq at STP. This is temperature, this is pressure, this is temperature. At standard temperature and pressure. So this thing, they will remove it. What you do is ATM, standard ATM, like we taught in the other class, is 1 ATM, 1 atmospheric pressure. So standard ATM is 1 ATM. And the temperature, standard temperature is 273 Kelvin. So impute them and you solve, you get your answer. There's no two ways about nothing out there. It's just for you to focus. Read your question first, remember, so that you understand and know how to answer your question. Okay, I know that with this we have done justice to ideal gas equation. You remember Boyle's law is talking about pressure and volume, which is pressure is inversely proportional to volume provided that temperature is constant. Charles' law saying that the pressure is directly proportional to temperature provided that volume is directly proportional to temperature provided that pressure is constant. General gas equation is the combination of Charles' law and Boyle's law. While ideal gas equation says that for a gas to be an ideal gas, it must have pressure, temperature, volume, and number of moles to meet the with the molar mass constant of the gas. So if you have this, I think you are okay for Charles' law. There are other laws we are going to talk about, but for the fact of this class, we are going to, these are the gas laws that I know that you find interesting to know. Okay, with respect to Boyle's law, know your formula first. Know your formula. I would like to let me throw small light so that you will not be taking unawares. Know your formula. Know the formulas. Know the formula. The formula of Boyle's law says P1 V1 equals to P2 V2. Charles' law says V1 T1 V1 over T1 equals to V2 over T2. While general gas equation says P1 V1 over T1 equals to P2 V2 over T2. Ideal gas says PV equals to nRT. PV equals to nRT. Okay, with respect to this, I think I have given you enough for this gas equation. What I want you now to do is to go back to your books, look for more examples, practice so that you get perfect. Share, like, subscribe to this channel so that you have more, so that they will still refer us to other people. You can still try as much as possible to tell your friends concerning this channel. Thank you so much.